Lecture 2 or 4, we are going to discuss on Poisson distribution. So the learning outcome for this lecture is at the end of the lesson, students should be able to identify Poisson distribution, which is represented by P naught and lambda as the parameter. And the second learning outcomes is to find the mean and variance of Poisson distribution. And the last one, to find the probability by using Poisson distribution. So this is the man that found the Poisson distribution or create the Poisson distribution according to the experiment they have. So it's Simon Denis Poisson. It's a French mathematician. That's why we call it Poisson, not Poison. This is a name in France. Okay. So from UMASS, what is Poisson? The Poisson distribution applies when the event is something that can be counted in whole number and the occurrences are independent. Also, the average frequency of occurrence for the time period in question is known. So we know what are the average. And it is possible to count how many events have occurred, such as the number of times a firefly lights up in my garden in a given 5 seconds, or some evening, but meaninglessly to ask how many such events have not occurred. Okay, let's go deep into Poisson distribution. So the Poisson distribution is used to model the number of events occurring within a given time interval. So actually it's not exactly just time interval. It may be space or area or pages or anything in a certain space. Okay, let's say situation to be modeled by Poisson distribution are: an experiment consists of counting the numbers of times a certain event occurs, and the probability that an event occurs is the same for each interval. Then all these events occur independently. And lastly, the variable x is the number of occurrence in the given interval is written as x is such as the Poisson with lambda as the parameter of the Poisson distribution, and lambda must be more than 0. When the Poisson distribution is appropriate, the probability of exactly x occurs is given by the formula. So the probability of x equal to exponent of the power of negative lambda, the parameter, multiply with lambda to the power of x, the certain we want to find, and divide with x factorial. So this is the probability distribution function for the Poisson distribution. And then the mean and variance of Poisson distribution. If x is a random variable following the Poisson distribution, so x is a Poisson with lambda as the parameter, then the mean and variance of x is equal to lambda. Both are lambda. So lambda is the mean, also lambda is the variance. That's why we have to know, we will know the average of the events happen in a certain interval, because the average means a lambda means a and mean is the mean. Example 1. If x is a Poisson with 6 as the parameter, find the probability by using Poisson formula. So for question number A, we want to find probability when x equal to 3. So if it's equal, then we can just substitute the value of x equal to 3 into the formula with lambda equal to 6. So probability for x equal to 3 is equal to, so what is the formula? Exponent to the power of negative lambda. So our lambda here is 6. So this is our lambda. So e to the power of negative 6 and lambda to the power of x means that 6 to the power of 3 divided with x factorial, which is 3 factorial. So by using calculator, we will get the answer as 0.0892. How about question number B? So we want to find probability of x more than or equal to 2. Okay, so we have lambda equal to 6. So what we can find, so if we want to find this value of x more than or equal to 2, it will include 2, 3, 4, 5, 6, 7, up to infinity. Okay, it's not like binomial because we have certain value of number of trials. But for this one, what we need to do, we have to find using the complement. So if 2 up to infinity is included in the probability, so we can use the complement by subtracting the other part, which is what is not included in this x more than or equal to 2. Yes, x less than 2, which is it includes 0 and 1. So we can just subtract 1 for the 1, which is the total probability, with the x equal to 0 and x equal to 1. So for this x equal to 0 and x equal to 1, we use the formula to get. So 1 minus, yes, e to the power of negative 6, the lambda, and the lambda 6 to the power of 0 divided by 0 factorial, and then e to the power of negative 6 multiply with 6 to the power of 1 for x equal to 1 divided by 1 factorial. So by using calculator, you will get the answer equal to 0.9826. Okay, so for question C, how about C? This is for probability of x less than 2. So what are included in x less than 2? Directly, it is equal to x equal to 0 plus with x equal to 1. Okay, so it will be complement of question number B. So we found already what is probability of x equal to 0 and x equal to 1 in question B. So repeat back, so we get the answer 0.0174. The same as the complement of question B, right? 0.017352. And for question D, probability of x in between 3 and 5, where 5 included. So what include in this interval? So it will be 4 and 5. So find the probability for x equal to 4 and x equal to 5 and put in your calculator. So you will get the answer equal to 0.1339. Okay. 0.2945 as the result. Total up between these two values. Sorry. Okay. So the next example. Example 2. If x is a Poisson with 5.5 as the lambda, the parameter, find probability of x more than or equal to 5, probability of x less than or equal to 5, probability of x equal to 5, and probability of x in between 3 and 8, where 3 must be included. Okay, so now let's try by using the table. So we have a Poisson distribution table in your statistical table. So because we have lambda 5.5 inside your table, so we just use it. So the same as the probability for the binomial distribution, the table give you the probability of x more than or equal to x. Okay, and then our parameter is only 1, which is the lambda. So for x, probability of x more than or equal to 5, we just look at r equal to 5 and lambda equal to 5.5. So what is the answer for this one? So we look at this column, and then this row 5, which is, we will get the answer 0.6425, probability of x more than or equal to 5, directly from the table. But for question B, probability of x less than or equal to 5, so what's included? 5 and below. So what is not included is 6 and above. So what we can do is to rewrite it as 1 minus probability of x more than or equal to 6. So what do we have here? So 1 minus, what is probability of x more than or equal to 6? So following this row at r equal to 6 and lambda equal to 5.5, so we have the value is 0.4711. So 1 minus 0.4711, we have the answer 0.5289. Okay, next question, question C, probability of x equal to 5. Okay, so x equal to 5, the same as binomial, because Poisson is whole number, so it's a discrete random variable. So we can use the same formula, which is probability of x more than or equal to 5 minus probability of x more than or equal to 6. So which one is more than or equal to 5? It is equal to 0.6425. And then for x more than equal to 6, it is equal to 0.4711. So 0.6425 minus 0.4711 is equal to 0.1714. So this is answer for question C. And lastly for question D, probability of x in between 3 and 8, where 3 must be included. So what do you think about this one? So as I said in the binomial, we have 3 and 8 here. So 3 must be included. So we put the dense dot here, and 8 it must not be included. So empty dot. So 3 must be included, 8 must not include. So we can take probability of x more than or equal to 3 because we want to have the 3, but we have to subtract from 8 to infinity. So this is equal to probability of x more than or equal to 3 minus probability of x more than or equal to 8. Okay, so what is probability of x more than or equal to 3? It is equal to 0.9116, and x more than or equal to 8 is 0.1905. So subtract from the probability of x more than or equal to 3, we get 0.7211. So that's for question number 2. Example 3. So if x is a Poisson with 4 as the parameter, find the means and variance. So what do you understand about the mean and variance of Poisson? Okay, by definition, the lambda itself, which is the parameter, is the mean and also the variance. So directly we give the answer mu, or the expected value, is equal to 4. Also the variance is equal to 4. Okay? Simple, really simple. Example 4. Given that x is a Poisson distribution with means lambda. So if mean is equal to lambda, so our parameter also is equal to lambda. So if probability of x equal to 2, x equal to 2 is equal to 2 times of probability of x equal to 0. Find the value of lambda. Hence, calculate probability of x equal to 2. Okay. So, how do you think we have to do this? We just need to substitute all the value we know into the formula of Poisson distribution, PDF, the PDF lah. So what is the formula? X factor of negative lambda multiplied with lambda to power of x. So what is our x when x equal to 2? It is equal to 2 and divide by 2 factorial, and equal to 2 multiplied with e to power of negative lambda and lambda to power of 0 divided by 0 factorial. Okay, so what do we have for this one? Rearrange everything, and this exponent power of negative lambda multiplied with lambda squared divided by 2 factorial is equal to 2 multiplied with e to power of negative lambda. Why? Because lambda to power of 0 is 1, 0 factorial is 1. And then expected of exponent power of negative lambda can be cancelled out. So we left with this one. Is supposed to be lambda squared. Lambda squared is equal to 2 factorial multiplied by 2. So lambda squared is equal to 4. So lambda is equal to, it's either 2 or negative 2. Can we have a value of negative 2? So what is the value of lambda? So lambda can be 2 or negative 2, right? So lambda can be 2 or negative 2. But remember, in Poisson distribution, lambda is always positive. So lambda should be equal to 2 only. So we have to ignore the negative 2. Hence, calculate probability of x equal to 2. You just have to substitute the value of lambda equal to 2 into the formula. So we have e to the power of negative 2, and the lambda is 2 to the power of 2 divided by 2 factorial. So we get the answer 0.2707. Okay. Example 5. An average of 3 cars arrive at a highway toll gate every minute. Means that what? Means that in every minute there will be 3 cars arriving at the toll gate. Average means that it's a mean, or the lambda, the parameter of the Poisson. So there are intervals in this distribution, which is every minute, in 1 minute. So this is a Poisson distribution. So x is a Poisson with parameter equal to what? Equal to 3. Okay, so find the probability that exactly 5 cars will arrive in 1 minute. So what we want to find? So we have to know what is this random variable talking about. So what is our x? So x is the number of cars arrive at the toll gates in 1 minute. Every minute means that 1 minute. Then x is a Poisson with 3 as the parameter. So the time interval is 1 minute. And then we want to find the probability of exactly 5 cars arrive in 1 minute. Means that probability of x equal to 5. So by using the formula, we get e to the power of -3, the lambda, and the lambda to the power of x, which is 5, 3 to the power of 5, divided by 5 factorial. So we have the answer here equal to 0.1008. Okay, the last example. An average of 6 telephone calls are received by department every hour. Right? Now, call received by department every hour. So every hour will be the interval that we have in this question. So this is a Poisson distribution. And then it said that average of 6 telephone call. So this 6 will be the parameter, which is average of the calls that they receive in 1 hour. So now we want to find the probability that 4 calls are received per hour in 1 hour. So what is the distribution here? It's a Poisson with a parameter lambda equal to 6. And then probability that 4 calls are received per hour means that in 1 hour interval we receive 4. So what we want to find is probability of x equal to 4. So equal to 4 means that we can directly use the formula of Poisson, which is exponent to the power of -6 and 6 to the power of x, which is 4, divided by 4 factorial. So we get the answer equal to 0.13385. Okay, so this one. Okay, and then the next one, the probability that 6 calls are received in 2 hours. So what is the difference in this question? Yes, the interval is changing. Why? Because for the x, the random variable we defined earlier, it's a number of telephone call received by department every hour. Means that in 1 hour. But now in 2 hours means that the lambda will be changing from 6, average of 6 in 1 hour. In 2 hours it will be average of 12. So the lambda will be 12. So now we want to find probability of 6 calls are received. So probability of x equal to 6. Right? So we have a new random variable here, x here. So when probability of x equal to 6, so just substitute the value x6, x equal to 6 and lambda equal to 12 into the formula. So it will be e to the power of -12 multiplied with the lambda 12 to the power of 6, which is the x, divided by x6 factorial, which is equal to 0.0255. And lastly, the probability that less than 3 calls are received per 30 minutes. Okay, so how to find probability of x less than 3 calls? So remember, this is in 30 minutes. What it means? What is the relation this 30 minutes with hour and hour? So it's half of 1 hour. That's why the lambda will be changing from 6 into 3. Why? Because we have to multiply by half lah. So x is a Poisson with 3 as the parameter. Now we want to find probability of x less than 3. Less than 3 calls. So it is equivalent to probability of x less than or equal to 2. So we can use the formula. So 3, we don't want the 3. So we can cut the ties here. So we can include from 2 and below. So we can find by using the table if we want to use the complement. So means that we want to subtract 3 and above, right? Because we want 0, 1, 2. So we have to subtract 3 and above. So it can be written as 1 minus probability of x more than or equal to 3. So following the table, for lambda equal to 3, the value of r equal to 3, it will be 0.5768. So 1 minus 0.5768 will give the answer 0.4232. Okay, so the parameter will be changing depending on the intervals in the question. So you have to be careful with that. Okay, so that's all for Poisson. Good luck. And thank you.